Today we're going to get into secant lines and tangent lines. In order to do a lesson on secant lines and tangent lines, we have to know what they are. So I don't know how familiar you are with Euclidean geometry, but when you have a circle and you draw a line through a circle and it hits in two spots, that's a secant line. And if you take the line and move it to the edge of the circle and only touches one part of the circle, then it's a tangent line. Has anybody have done that before? Anything in a circle? Okay, so the same thing with functions. If you draw a function and you draw a line that passes through a function twice, it's a secant line. And if it only passes through the function once, it's a tangent line. Okay, so secant and tangent lines. The first question today is we're going to find the slope of the secant line to the graph 2x between the points where x is equal to 1 and x is equal to 4. So graphically, I just want to show you what we're trying to find. If I draw an axes, the x and the y axes, we should be able to recognize that 2x squared is a parabola that's been stretched vertically by a factor of 2. So it's a function that looks like that. And I want to find the slope of the secant line between the points where x is 1 and x is 4. So I'll say x is 1 here. Okay. So x is 1 here. How would I get this value on the function? Where would I get that information from?
Inputting x into the function fx.
Right, so just taking 1 and substituting it in here and getting the value. Okay? So then x equal to 4 is approximately here. Exact same thing. I can plug 4 into the function and then I would get the value of that point. And what I'm trying to do is to come up with the slope of the line that passes through these 2 points that are on the function. And because it passes through 2 points on the function, it's a secant line. So to figure out the slope of this line, essentially I'm just using the slope formula, right? So remember the slope formula is the change in the y's with respect to the change in the x's. So the change in the y's is the function evaluated at 4, subtract the function evaluated at 1, over the change in the x's, which is 4 minus 1. Substitute 4 into the function. I get 2 bracket 4 squared minus 2 bracket 1 squared. All over 3. Doing some math. It's 32 minus 2 over 3, which is 30 divided by 3, which is, so the slope of that blue line is, so essentially finding the slope of the secant line boils down to finding the average rate of change. Okay, so you're finding the average rate of change between the point where x is equal to 1 and where x is equal to 4. Any questions? Okay. Next question. Determine an algebraic expression that represents the slope of any secant line that passes through the point 2 and 8 and the general point x and 2x squared. So as soon as you see the slope of the secant line, you should be thinking the average rate of change. I have to use the slope formula. So the change in the y's with respect to change in the x's, right, is the slope. And I'm just reminding you here that, remember, we use m to represent the slope. And back in grade 9, we learned to figure out the slope, we can take y2 minus y1 over x2 minus x1, and that'll give me the change in the y's over the change in the x's. And if I call this x1 and this one y1, this x2 y2, and I substitute them in accordingly, I get 2x squared minus 8 on the top and x minus 2 on the bottom. So this represents the slope of the secant line that passes through the point 2 and 8 and the general point x and 2x. The only thing we need to do now is see if we can simplify that expression. Is there any way of simplifying that expression? Better? Common factor? Okay, now common factor of the, got my squares there. And then what could I use? Really? Okay, so we factor using different squares, right? And then after we factor using different squares, we notice that there's a common factor on the top and on the bottom, so I can divide the top and the bottom by x minus 2, and I end up with a simplified expression for the secant line that passes through the point 2 and 8, and the general point x and 2x. Any questions? Okay. So, whenever you see secant line now, you should be equating that with the average rate of change. Okay? The tangent problem. So I know many of you are going on to next semester to take calculus. This is essentially where calculus was developed from, this problem. Two guys invented calculus at the same time independently, different parts of the world. Newton, which I'm sure you guys heard of, and Leibniz, which may be not as famous. But both of them developed calculus, and they both get credit for developing it. And for those that go on to take calculus, you'll learn that there's two different notations for representing the same thing. It's because we give respect to both of those mathematicians. So the tangent problem was, how can we determine the slope of a tangent line? So remember, a tangent line is a line that just touches a function in one spot. To the function f of x is equal to x squared. So again, I'll draw that, which is just a standard parabola. So I want to figure out the slope of the tangent line that at x equal to 1. So I'll say this is 1 here. And then I substitute that in, and I get that value. What I want to do is to figure out the slope of this blue line. So the tangent line comes along the curve, touches it, and then continues on. So I want to figure out the slope of that blue line. What problem do I have to figure out the slope of that blue line? Sure.
You only have 1 point.
Right, I only have 1 point. Okay. So this point here is the point 1, and if I substitute 1 into the function, I get 1 squared, which is 1. So I only have 1 point. To figure out the slope of any line, I need 2 points. What do I do? Okay. Oh, you gonna say something, not really. I could, but I don't know how that would help me. Yeah, Keith?
You could use that instantaneous rate of change to help figure it out.
How so?
In figuring out instantaneous rate of change, we only need 1 point.
Exactly. Okay. So what these two guys said is I need another point to do it. So I'm just going to pick another point on the function. It has to be on the function. Okay. And then I'm going to figure out the slope of that line, which is now a secant line, right? Because the secant line passes through 2 points, so it passes through this point and this point on the function. And I can figure out the slope of this secant line using my slope formula. So what value do you think we can use here? What would be a nice value to start off with, thinking about what we did yesterday?
1.1.
Perfect. So you would use 1.1 and then figure out the slope of the line between that green dot and the black dot, and that's the slope of the secant line. It's not exactly the blue tangent line, but it's a pretty good estimation of it. but then I would want a better estimation by doing what? Yeah. Yeah, you want to move the point closer. So what you would do is say, okay, I want a better estimation. That green line doesn't look exactly like the blue line. So I'm going to pick a point even closer so that when I draw the green line, it becomes closer and closer to the blue line. So essentially, we want to move the green line so close to the green point so close to the black point that it essentially becomes the same point and it becomes the tangent line. And that becomes the instantaneous rate of change. Does that make sense for the people who follow along? Okay. So now, whenever you see the slope of a tangent line, you should think, I need to do the instantaneous rate of change. And that is essentially the entire guide. Oops, that should be a Y. So to figure out the average rate of change, you get 2 points. That's the same thing as the slope of the secant line. To figure out the instantaneous rate of change, that occurs at 1 point, and that's the same thing as a tangent line. So to figure out the slope, we're just going to complete our instantaneous interval chart. So I will start at 1 and go to 1.1. So again, just in case you forget, I'll put this in the note. To get these answers, you would take f and substitute 1.1 into it and subtract off f at 1. You get that answer. Then you take 1.1 and subtract off 1 to get that answer. And then you would do it all over again, but you'd move the point closer to get a better estimation of your slope. And then finally, the last one I'm going to expect you to do is the third one where you get 0.00. Okay, so I've done the calculations for us. So this works out to be that, divide them through, get 2.1. This becomes 0.0201. So if I keep going and I move this point closer and closer, what do you think the slope of the tangent line is going to work out to be? Just by looking at what the values of the slopes of the charts are heading towards. All right. And that's essentially what calculus is. Okay, it's a rate of change, and you're moving your point closer and closer to it so that you get a perfect estimation. Okay, because that's all we're doing really right now is estimating. Next semester, we'll learn how to figure out exactly. Okay. This will be 110% the last question on your test. Okay? Determine the equation of a tangent line to the function at a particular point. Okay? And again, you're probably sick of me saying this, but those who go on to calculus, you're going to see this question probably 20 times, just with different functions and different values. Okay? Because this is essentially the quintessential calculus question, find the equation of a tangent line. Okay, so we're going to estimate it in this class. Next semester, we're going to figure it out exactly. So as soon as it says determine the equation, anything to do with tangent should say, okay, I need to figure out the instantaneous rate of change, which is the slope. Okay, so this is a little bit different. So because I want to figure it out at -2. So I'm going to use -2, and I'm going to use -2.01, 0.1, and 0.001, right? But when I'm on the negative side, so those 0.1s are on the other side. So really, technically, I should write it like this: -2.1 to -2. Because -2.1 is on the left side of -2. You guys know what I mean by that? And then -2.01, -2, and then finally -2.001, -2. So whenever you're writing an interval, you always want to write the left number first and then the right one. Okay, we've been in the habit of writing this and then the 0.1 on the other side because the positive one was always on the other side. Do you understand the difference? Okay, so now it's just a matter of filling out this chart. So those values. The change in the x's, right, for every single one of these interval charts should always be the exact same thing. Like, never change, right? So these guys, then you divide them through, and I get negative 29.32, negative 28.102, and negative 28.0. Okay, so when you're dealing with the slopes of the tangent lines, I'll get you to round it off to the nearest whole number that the slope's approaching. So what does it look like the slope of the tangent line is in this case, David? Negative 28. So we're going to use negative 28 as my slope. That's the first thing I figured out. But I need to figure out the equation, right? And the equation of a tangent line is a line. So all equations of lines are in the form of y equals mx plus b. We just figured out the m. Now we need to figure out the b, right? So to figure out the b, I'd write y equals mx plus b. Then I'm going to substitute in my m, because I know what my m is. I'm going to substitute my x. I know what my x is. And I can figure out my y. How do I figure out my y? Yeah.
Substitute negative 2 into the original equation.
Perfect. So substitute negative 2 into the original equation, and that'll give you the point. And if you do that, I believe you get 19. So then I get 19 for y, negative 28 for m, negative 2 for x, plus b. 19 is equal to 56 plus b. Bring it over to the other side, and I get negative 37 when I collect my like terms. So then therefore the equation of the tangent line is y is equal to negative 28x minus 37. Any questions? So 110% you get a question like this. It's very disheartening when people leave this question blank. Okay? Also be careful, especially with the negatives. When it's a negative, make sure that you write the negative 0.1 on the other side. Okay? And make sure you round off your answer to the nearest whole number, and then figure out the equation of change. Doesn't get any harder, any easier than this. The only thing that's going to change is this function right here, and this value right here. All right. So, can't stress this enough. If you understand how to figure